So remember what we had in the previous example, the video, we said this thing here is actually a square binomial, so is x minus 3y all squared minus a squared, and you realize you've got difference of two squares, so this factors as x minus 3y minus a into x minus 3y plus a, and we are done. Okay. So what is happening here again, you've got to be careful. You have 5 terms actually now, you don't have 4. And I think you should have seen the drill now. Usually when you get 5 terms, it suggests that you actually have to factorize first of all, maybe some form of a trinomial or maybe another binomial. In this case here, we actually had a trinomial, but which happened to be a square binomial. What is happening here is quite interesting. If you look at what is happening, you can maybe try, say, factorize this. And if you factorize this, you can see, again, it's what? It's a trinomial. And the interesting thing about this trinomial is that when we factorize it, actually, we are not really going to start right away with the Portion law method or the way we factorize a quadratic trinomial. We're going to notice that there's actually a highest common factor. In terms of numbers, 2 goes into 2, 6, and 18. In terms of variables, y actually is also common in every term of this block here. And you can realize actually somehow the grouping here is quite nice, because what is left on the other side here is actually the difference of 2 cubes. So you see why I reserved grouping as the last point of discussion in our talk. Therefore, I can factorize the difference of 2 cubes. I know I've got to take the cube root of x cubed, that is x, minus the cube root of 27. I believe it is still 3. And then I know that what I've got to do next is to square the x, that becomes x squared. I swap the sign, that becomes plus. I multiply 3 and x, it becomes 3x. I square the negative 3, it becomes a positive 9. I put that plus here, right here, and I take out the highest common factor, which is 2y. So coincidentally, maybe, it happens that when I take out 2y in every term, I'm left here with x squared. Here I'm left with 3x, and there I'm left with a 9. Of course, you just got to take this term divided by 2y, that term divided by 2y, and that term divided by 2y. That's the truth. And so I can take out now a block here, which is common, that is x squared plus 3x plus 9. It is common in both terms. So I will then say, well, x squared plus 3x is the highest common factor at this point. What remains when I take it out here, I have x minus 3, and what remains there is a 2y. Once again, don't be tempted to add x and 2y or a negative 3. Leave it like that. There are no like terms. You must be disciplined enough. So here's the interesting thing. I should have mentioned this when I was discussing the sum and the difference of 2 cubes, that whenever you factorize and you've got a quadratic in the other term, or in the other product rather, you will find in most cases, more especially that you are now in grade 10 and you have been introduced to this, that you actually don't have to stress about factorizing this. But in some cases, it is possible to factorize that. So let's just check here if this thing can be factorized, okay? And obviously in this case it can't, but let's see, how do you check? So we're going to continue with our U method. The sum, if I were to work on this quadratic and factorize it, the sum would be as follows. Well, should give me a negative 3, and the product should give me a 9. But I know the sum, the way it works is I divide it by 2, then I have to add one particular number, which I am going to find using the product. So this will be negative 3 over 2 plus a u into a negative 3 over 2 minus a u. This should give me a 9. And we know this is always going to be the difference of 2 squares. So this is 9 over 4 minus u squared is equal to 9. So you realize you have 9 over 4 minus 9 is equal to u squared. Without even pressing a calculator, if you think about it, 9 quarters are actually less than whole number 9. So you can just go ahead and say 9 divided by 4 in your calculator minus 9. Just press it as it is. So we are getting here a negative 27 over 4, which is u squared. But to find u, we actually have to take the square root on both sides. And we know that the square root of a negative number is a problem since we're dealing with solutions or numbers in the real space, the real number space, so to say. So at this point, you can see already, since u is going to produce a negative square root, that there is no solution here, or there is no real number that there are no real numbers that we can add and they give us a negative 3 and a product of 9 for that expression. In this case, we will stop here and know that actually we are fine by leaving the answer at this point. So that is how you will actually verify whether you need to factorize the quadratic further or leave it as it is. That's about it from me, guys. It has really been fun. Once again, as usual, recording the stuff and explaining them to you. I hope I have shed some light. You have seen some cool stuff that you probably adapt into your mathematics. And as usual, I'll leave you with a nice example here, rather a nice set of problems to look at. I select these problems so that I test certain processes in you to see whether you've been paying attention or you have actually understood what I have been saying all along. So go ahead and see if you can do this on your own. Of course, as usual, you're welcome to chat with me, and so that we can explain any other thing that may be strange to you. Remember, always ask why. Why do you do something in math? Where does it come from? If you don't get an answer, you are probably getting yourself into trouble. So go out and find out why do you do many other things that you do. Okay, guys, cheers.